In the last chapter, I said there were three things that we needed to know and understand before we move forward. One of those three things were control structures. There was sequential, selection, and repetition control structures. In this chapter, we are going to look solely at selection control structures or decision control structures. I prefer decision. Decision, selection, same thing, potato, potato. So let's talk about decision statements. In JavaScript and in other programming languages, there will often be a time where our code needs to make a decision. And some code is going to execute based on that decision or not execute based on that decision. We're going to take a look at some different flowcharts to help us understand this concept. Flowcharts are often used in programming to help us determine the logic of a program. A single alternative statement or single alternative decision statement. When we begin this statement, we are testing to see if a condition is true. If that condition is true, following this flowchart logic, we would execute one block of code statements, and then we can follow the program to the end. Now, if the condition was false, it would go straight to the end of the program. To see what this looks like in code, this is an if statement. We would have if, the keyword if in JavaScript, a test condition, which we usually put in parentheses. We'll talk more about test conditions later on in this lecture. And then inside a set of curly braces, we have a code statement or several code statements. These code statements are only going to execute if the condition is true. You may also have instances where you have dual alternatives. So let's take a look at this. It is similar to the single alternative in that if the condition is true, we execute a block of code and then the program ends. But in this case, if a condition is false, we execute a different block of code and then the code ends. In JavaScript, this looks like an if-else statement. We have our keyword if, our test condition, and a set of curly brackets that contain the code that will execute if the condition is true. Then we have the keyword else, a set of curly brackets, and the code statements that will execute if the condition is false. If this test condition is true, this code never executes. If this test condition is false, this code never executes, okay? Only the true code executes if the condition is true under the if, and only the false code executes if the condition is false under the else statement. Now, if we can have if else, we can have multiple alternatives, okay? And there's actually two different ways that we can do this in JavaScript. We can use what's known as an if-else. Let's first back up and follow the logic of this program. So the true condition is just like the previous two examples. If the condition is true, we execute a block of code and then we go straight to the end of the statement. But if the condition is false, we check for another condition. If that other condition is true, then we execute a different block of code and then make our way to the end of the statement. If the condition is false, we execute yet another block of code. There are three potential outcomes in this case, in this particular flowchart. There are three different blocks of code that will execute based on whether a condition is true or false, whether it's true or false. This code is an if-else-if statement. If a test condition is true, then a block of code will execute. Else, so that condition was false, we test for another condition. In that case, if that condition is true, we have the true code that executes. If this condition is false, then this code executes. okay? So if our first test condition is true, this code executes, and then we exit this statement. But if this test condition is false, we either have this code that executes or this code that executes. This is not the only multiple alternative option we have in JavaScript, though. We also have something called a switch statement. I will commonly refer to it as a case statement because that's how I was taught. A switch statement begins with a keyword of switch. We have a test expression, not a condition, a test expression. And we have multiple cases of that expression that we will test, and different code statements can execute based on that. So don't panic. We're going to save this for the last of this chapter, and hopefully it'll be super simple by the time you get there. But notice that we do have these keyword breaks, and we'll talk more about what those do when we get to switch statements. We're going to start off with ifs, so don't panic. Now, with the if statements, there's one really important thing that I want to point out here. After a if or after an else statement, JavaScript by default looks for one line of code. So we could technically leave the curly brackets off if we had one code statement. Not statements. If we had one code statement, it would execute one code statement. But for the purposes of our class, and since we're just getting familiar coding, we are always going to leave those curly brackets there. So we'll have an if, a test condition, a set of curly braces. Else, a set of curly braces. And I'll show you why in a demonstration in just a moment. Okay. So what are test conditions? Now remember I said the test expression in the switch statement is a little different than the test conditions that we have in if and if else and if else if statements. A test condition is an expression that is either true or false at the time the code executes. It is not going to ever be anything else. When you write a test condition, you need to keep that in mind. Does this test condition, or at the time of this code's execution, will this test condition either result in true or false? That's all they can be. They can't be a new value. You can't assign new values in a test condition. They either need to be true or false. Therefore, they usually involve our conditional operators like less than equal to, greater than equal to, the same as, are not equal to. And often they will involve our logical operators like and, or, and not. So you have to think about a computer does exactly what you tell it to. You have to be very specific. And it has to be in the language that the computer can understand. So humans, we extrapolate data based on a certain question. So if I said, are you old enough to drive? Well, in your brain, you know how old you have to be to drive in the state of Mississippi. You know if you're that age, and therefore you can answer that question. But the computer has to be explicitly told what that means. So if we had a human question, or are you old enough to drive, the computer question would be something like, is age greater than or equal to 16? Okay? If you are 16, this condition would be true. If you are 14, this condition will be false. Okay? Often your test conditions can be written in more than one way, and you need to keep that in mind. So we could also write this as age greater than 15. If we are only accepting whole numbers, and a person can only be 15 or 16 and not 15 and a half, any age greater than 15 would be able to drive or be old enough to drive. Let's look at another human question. Did you fail the test? We could write that to the computer, is your grade, a variable called grade, is that value less than 65? Or you could write it as, is that value of grade less than or equal to 64? So any grade that is below 65 is a failing grade. Any grade that is equal to or below 64 is a failing grade. What about if we asked, was the game tied? Well, how could we tell if the game tied? Well, the computer needs to know a value for the team 1 score and a value for the team 2 score, or whatever you referred to these scores as. And then you could check for equality using our exactly the same as. And then finally, we could even have these compound test conditions where I says, it's been a long day, guys, where if we asked, is it the weekend, the computer needs to know what days the weekend are and what days are the weekend. The weekend, it could be a Saturday, the weekend could be a Sunday. So in this case, we would have, is day, a variable called day, the same as Saturday, is a variable called day, the same as Sunday. And notice that we used our or operator here, our logical operator. And on each side of our logical operator, there is a full test condition. So this is a full test condition, and this is a full test condition. I did not say, is day exactly the same as Saturday or Sunday. That would not work. And we'll talk more about that when we get to compound conditions, but I just want to make you aware of that. Okay, so jet on over and let's practice with some JavaScript.